Okay, hey everybody. This is TripleO deep dive session on networking. I think the topic today we're talking about is mostly the physical over cloud networks. Is what I got on the Etherpad that we wanted to go over. So that would be stuff like OSNet config, how that applies to heat templates, and all the way through how that actually gets deployed on the overcloud instances. So you guys want to see my dev environment, and then from there kind of jump around and ask questions. Would that work?
Yep, sounds good, Dan.
Yeah, that sounds good to me. Let's do that.
And Dan, I don't know if it's worth it to show right now, but Liz has been doing a lot of work with the network topology stuff that we're going to present in the UI, so it might be worth something to show later.
Okay, cool. Yeah, we could switch over to another screen share. Can you guys see this screen here? Can everybody see that?
A bit bigger if you can, Dan.
How about that?
Perfect, thanks.
Yeah, even better.
Okay, so yeah, I actually went ahead and pre-deployed an overcloud just so we had something to work here. So this is just a controller and a compute instance. And so a little bit of background about my environment. This happens to be, these are physical machines that I'm using. I've got a Cisco switch here that's got VLANs set up for trunking. The ports on them are trunking so that I can run isolated VLANs for the overcloud networks that we use for deploying the overcloud. And what else do I need to say? My undercloud, I've got a couple of VLANs there as well for just convenience, but those aren't required. So I guess let's just go over things from a high level. Before we get into VLANs and whatnot, if you're just starting with Instack today, the first thing you'll have one neutron network there called the control plane, which is what we use for provisioning the instances. And that can be used for everything. So the sort of simplistic deployment case would be to use the control plane and then use tunneling on top of that. GRE or VXLAN for your tenant traffic. That's a very simple use case. You can kind of do everything on that single network, and that'll work. But for a little more robust deployment, a lot of people want to isolate the traffic and be able to control things a little better, at the switch level. And so what you can do is you can switch over to a variety of it's almost, we'll get into the options here. It's almost infinite what you would actually could do with this. But it's a templated based networking setup approach. And so what you end up with is, so I have neutron net list. So on my undercloud, I actually have 6 networks. So in addition to the control plane, there's 5 other networks there. And you can see here, just right off the bat, that each of these networks is using a different CIDR subnet. And all mine are pretty small. I've just got various /24s here in the Class B range. This is, and one other thing to point out, so all of them are, in the Class B 172 range, except for the external, actually have that routing back to my sort of local network where my laptop is, so that I can actually SSH into my instances. So I'm kind of sort of treating that locally as like a real external interface. But how from an end user standpoint, how do you enable this? So what I have is, in addition, when I deploy things, I have a couple of, this is how I set my 10 dot range here. There's heat parameters for that. And then when you deploy, you can basically just I've sort of mocked this in for a demo just simplistically, but you can basically add extra environments to enable network isolation is the feature we call it. So we've got, the down here on line 3, there's the network isolation environment. That's going to enable a bunch of heat nested stack resource overlays that enable network isolation. And so we'll go into what those templates look like and what they do in just a second. And then the second line here, so there's really 2 pieces to network isolation. One is enabling network isolation, and the second one is enabling your custom configs for network isolation. So there's sort of 2 pieces. And so the second part is something that you may want to customize for your own environment. And it was built specifically for this purpose. Can everyone still hear me?
Yes.
Okay.
Yeah.
Cool. Just wanted to make sure I wasn't talking into a black hole here. So I've got a bunch of stuff here, but I was going to go into the TripleO heat templates directory. Those 2 environments that I just showed you. So this one, network isolation, it's basically, it's a standard heat environment, but it basically overrides a bunch of TripleO resources with things in the network directory. So you're going to see here at the high level, there's these resources at the top. These are actually creating the networks. These nested stack templates actually create a neutron network, and they create a neutron subnet. So each of those is something that, by default, if you don't use network isolation, you're going to get just a no-op, and it's not going to do anything. And if you enable network isolation, you're going to get an extra network and a subnet created right off the bat. And then these things down here are what we use to create ports on the networks above. And so, one future thinking comment or thing here that I think will happen in the future is we're kind of moving towards templatizing some of this. So this is a heat template, but we're actually sort of moving towards generating some of the heat templates with Genja templates. And I could imagine that making the networks, the number of networks we have, more flexible and auto-generating this format would be something that's entirely possible. But right now it's static. We have 5 networks, and an optional management network is there. You can uncomment that as well. But let's start going into the network directory. Most of the stuff that's related here is inside the network directory. At the top level in the network directory, these templates here are what's creating the actual networks. So let's just look at the tenant network, because I think that's pretty familiar with most people. So inside of this template, there's normal heat parameters, and these parameters you can use to control the CIDR and how the networks are created. For the most part, you're not going to need to mess with these. Then the types of networks. So we're only using the neutron networks here for basically IP address management. So we're only using them for IPAM. And because of that, we've exposed some other options here, but we really, for the most part, don't need those. We're basically using them for port assignments. So the things you're going to want to control are the CIDR and the allocation pool. So this would be this CIDR here would be a common one, and then this one down here is if you wanted to reserve a couple of IP addresses at the beginning and the end of the range, you would then modify this allocation pool just to give yourself a couple of reserved IPs on that network. So and so again, this is something that in the overcloud, this network gets created, but it's an undercloud resource. So back to neutron net list, this tenant one right here. I created it, and it's a 160 or 172.16 network range. So you create your overcloud. During the creation process, it's gonna create this network. I'll actually show this at the end. We'll delete my stack and we'll do it again. But you'll notice the heat is one of the first things it's gonna do when it creates your overcloud is it's gonna create the actual network. And so Okay, so the next part is assigning ports on the network. And so the way this works is we've got a bunch of ports abstractions inside this ports directory. And so, again, we'll just follow the tenant one. There's some things in here to note about external. So you can basically there's some ways to sort of externally configure some IP addresses with TripleO. We might get into that later, but for the most part, again, you don't need to tweak these too much. If you wanted to name the network something different, like besides tenant, you could modify this name here. So if you called it tenant 2, this is sort of put into place where with an idea towards if eventually we had multiple overclouds that we deployed, we would want to probably name the networks differently so that there wasn't confusion. But for the most part, this nested stack is just creating a port. It's creating an OS neutron port object, and it's returning outputs that give you a convenient way to access things like the IP address, and the IP subnet. So yeah, pretty simple there. Any questions on this stuff? So I'm getting feedback from somebody, by the way. But the next thing is the configuration of the ports. So at this point, what we're looking at here is we're looking at the network config directory, and we've got what I would call 4 reference implementations. And so if you're deploying a cloud, what we're shooting for here is common use case references that you can either use out of the box or you can use with minor edits to deploy your overcloud. So we've got an example for bonds, one that uses multiple NICs. So that would be if you had 6 networks, you could have 1 network per NIC. This last one uses a single NIC, or the last 2 use a single NIC with either Linux Bridge or VLANs to basically isolate the traffic. So in my environment, I'm actually using single NIC with VLANs. So let's just take a quick look at that. We'll start with compute node. Let's see. So here, this is again a nested stack. Now I'll actually show how this wires in to the compute role in the heat templates as well. But this is a nested stack. What's passed into it is the actual IP addresses. So these IP addresses are what has been created off of the ports. So we've got the networks. They're created for IPAM. The ports are created off of those networks, and then those IP addresses and subnets are passed into this template and basically used to wire up the. So this is a template that for every single instance, every single Nova instance, like overcloud host, compute host, controller, etc., those would run this configuration locally with the parameters at the top of the template. And so basically, this is below this line here, so below OSNet config, this network config section, all of this data at this point is basically formatted for OSNet config. And so if you want to write your own templates, the thing to note here is that you can copy one of these existing sort of computer controller templates, and then you could basically customize this section here. So if you had let's say you had 2 NICs and you wanted to do some VLANs on one of them, but the other one you wanted to keep it separate for some reason, for just you could do that. Or you could have 2 bonds. If you had 4 NICs, you could have two bonded pairs, and you could do that. So all of that can be modeled with these templates, and then the IP addresses for the resulting overcloud instances will be substituted in by the heat engine and then applied locally. And this wires in I'm back at the top level here in my templates directory. So if you look at Puppet Compute, down network, I'll just search for network. So the network config, yes. So I mean this resource here, so you can see this type, OS TripleO compute net software config. I'm going to copy this and I'll show you how it wires in. So in my environment, I've got environments, net, single NIC, VLANs, with VLANs. So you can see this resource here corresponds to that template we were just looking at. And so that's how this, it's all just layers. So you enable network isolation, and that gives you all the networks and the ports. And then you layer on this config on top of it, and that's what drives the whole thing via heat. So here, so any questions about this? So I'm going to go into my compute node now. 6. I'll go to root just because it's nice and I can. So I mean, you can see right off the bat, I've got VLANs for all these network interfaces here. And this was driven by OS collect config when the node was provisioned. So we can actually watch that happen. But what happens is, when OS collect config runs, OS collect config, for those not familiar, is our agent in TripleO, and so it basically allows us to gather heat metadata. So it either gets the heat metadata from a variety of collection methods, but usually right now the default is Swift. And so it would basically gather the heat metadata and then apply it locally on this machine. So it's just an agent, and anytime there's an update, that agent's going to apply the update. And so ultimately what happens is, OS collect config just runs os net config, a config file, and the default config file is in etc os net config. So, I mean, and by default, that's not going to do anything because the tool itself is meant to be idempotent. You can see there's no changes, but this list here would have been what it didn't mark. Let me do it like this. I just wanted to show the debug output, what it would do. So, it's basically using that config file, and you can see what's in the config file here, the bridge name, and then all the VLANs down here. And this is JSON, so heat converts the YAML to JSON on local disk. OS net config can actually work with both formats for convenience. And then this is, basically just going through and showing what's generated, and it's deciding whether or not it needs to make any changes. So yeah, I mean that's how I can show you the actual file. That's how this wires up, and so this data was, from the heat template, parameters were substituted in. Those contained, custom IP address assignments for this host. And, the template is what told us how to configure this stuff on VLANs. And then OSNet config, applies that locally, brings everything up, and then we're good to go. Any questions about how this is working? One thing I wanted to mention, I'm going to go back out here, is during the provisioning process, we have a check in place that basically it's a validation check that ping tests all of the interfaces on all of the instances. And so, the nice thing about this is that what it's going to do is, as you're deploying pretty early on during the stack deployment, before any of the software configuration stuff runs. This is going to verify, if you're using VLANs, this is going to verify that all the VLANs are actually working back to the common ping points. And I think it's pinging back to the first controller. So what's going to happen is every node is going to ping back to an interface on the first controller node. And the reason we went with that logic is because the controller is the currently the only machine with interfaces on all of the networks. So that was really the reason for that logic. But this allows you to test in user space on the machines that essentially your switch is configured correctly. If this check failed, one thing that you might do if you saw a ping test fail on the tenant VLAN, for example, one thing that you might check would be to make sure that your switch is configured properly with VLAN trunking on that network. So you could double check that, and I've seen that happen, and it's useful for that. One forward-thinking note here would be, this check, while it does occur early in the heat stack creation, it would be really nice to have it occur during node introspection. So to do that, we would need to sort of refactor where we're doing our IP assignments and do that much earlier in the process. And so we would be doing that, either via another heat stack, just a totally isolated heat stack, or via another mechanism and then passing all of those parameter assignments into the heat stack. I think that's possible, but it would require a little bit of refactoring, and we would need the introspection RAM disk to support a validation of that type. But the end user impact of that would be pretty large, in that you would be able to determine much earlier in the deployment process if your physical networks are wired up correctly and stuff. So okay, any questions on this? One other thing, we got a chat message here. No questions. One other thing we can go over is, in OSNet config, I actually noticed in preparing for this demo that we don't deploy these samples as part of the OSNet config RPM. So it would be nice to do that. But if you check out the source for OSNet config, so we've got, you can check this out from git.openstack.org. There are some nice examples for the various switch types and bridges and all kinds of stuff that we support. So, OSNet config as a tool is really built upon, the idea of taking some YAML or some JSON and, making a tool that idempotently applies it locally and makes it so. So, and the sort of objects that we're configuring are, bridges and interfaces and VLANs. And so those abstractions apply to several different provider types. So there's an underlying provider mechanism, and there's an ifconfig provider that works with RHEL, CentOS, Fedora type distributions, and there's an ENI provider that would work with your Debian derivative distributions. And that one I don't think has nearly as much feature. I don't think, for example, the bonds work, but the basic interface support there for like interfaces and VLANs and stuff should be in both. But what we're looking at here is we're looking at a directory with examples for how to do things like bonds. You can see bridges with VLANs, interfaces. I think a new one, this one just landed today, the NFV switch. That would be something you would use if you wanted to use like DPDK on your compute hosts. You could wire them up with the optimal switch there. And then some of the networking vendors are actually are pushing patches to configure like IVS. There's stuff to configure that as well. So I like these examples because we have pretty good coverage of what you might do. There's a bridge with DHCP. Bridge with DHCP is a very simple example. And so we can look at the YAML. Or actually, I'm looking at the JSON. Let's look at the YAML. So this is just, it's going to create a simple OVS bridge. It's going to listen on DHCP, and it's going to attach one interface. So, this is something that could be useful. We have the same sort of example template that's a default in TripleO heat templates. Here's a Linux bond. So if you wanted to customize these, you'll notice here this is network config. So you could basically take this exact, what you're looking to model here, take OSNet config, the tool, test it locally on a few machines, and make sure it's doing what you desire to do. You can see here there's things like bonding options. You can control, LACP modes, all that stuff. There's abstractions in place to be able to get at those sorts of parameters. And you can control which interfaces get assigned. And then you could basically take that and go over to your heat templates, and I'll show you again where that goes in the network config directory. You would basically probably copy one of the directories here and then start modeling what you want to happen. And so again, now that's going to occur under this section here in the network config here. So this again is just the same thing that you see in the OSNet config tool. So that's, I think, a pretty good coverage of how the low-level physical networks are wired up. Let me see here. I can delete stack, delete over cloud. We'll just delete this. Wait for that to delete. And any questions while this is happening? I'm not actually sure this is going to happen, but it should happen. What I was going to show next was I was going to bring up a new overcloud and just kind of try to attach in process and show, when a machine first comes online, show what it looks like. At first it'll have just the DHCP assigned address from Ironic and Neutron in the control plane, and then show how OSNet config is run, and then the validations run right thereafter. Yeah.
That delete from yesterday.
What's up?
That delete looks like it's from yesterday. Sheet 10.
Maybe it was just hanging. Let me try it again.
That's the stack creation time, so it doesn't relate to when the delete was triggered.
I was going to say, I just brought this up last night, so unless there's a list. Yeah, I should be close. It should be, let's see. It's just taking a little longer. This is physical machine, so maybe my Ironic's just hanging. This isn't normal, but cutting edge development environment here. That's what you get. All right, it's gone. All right, so I'm going to actually go, I'm going to open a TMUX session just so I have multiple windows. And so this is my deployment. I've hacked in. This is not TripleO.sh, but for demo purposes, it's faster. So just trust me. So this will create a new stack. let's make sure it kicks off. And the one thing to note is, if you haven't watched this closely in the past, I mean, one of the first things that happens when you spin up an overcloud is see all these external networks created and stuff. That's basically recreating the networks. Here you can see it's creating ports. Some of those ports are for virtual IPs, and then eventually it's going to go down and start creating the ironic Nova servers. And at that point, once it gets into there, it'll actually create ports. Heat will create ports for the individual servers. So, again, we're just using Neutron in the undercloud as an IP address management tool, and this is, this dovetails in nicely with Heat as a way to roll out IPs to the network. So, window, create a window. We're going to wait for my Nova nodes to come up here, which could take a minute. Now is a good time for questions if anybody has them.
It looks like there's a question in the chat from Steve. He wants to know why we put the Keystone Public Network on, or the Keystone Public Endpoint on the internal API network. Is that what you're asking, Steve?
Yeah, I mean, I understand the control plane, why you did that for the admin. At least there was a comment addressing why, but I can't understand why the other one was done that way.
I think we were trying to choose a network that was available to all the nodes, and so the API network is one that basically I think every node. So when I say no, I mean role. So the roles, like Nova, or I'm sorry, compute, controller, storage, all the storage types, Ceph, all that stuff. They all basically have the internal API network. So by doing it this way, we basically ensure that it's there. But does that answer your question?
Well, I mean, when I think of the external API Keystone, I would assume the external people will want access to it. And if you're doing the internal API, you probably don't have access to it.
Yeah. So if you want to make changes to this, if you do want to make changes to this, let me go to a new window while this is happening. Inside of the TripleO heat template. So this is more of the service net map. Where is that service net? There it is. Yeah. So this is what you're asking about? Why this? Golly. Yeah, there it is. Keystone Public API Network is why it defaults to that. Yeah, I mean, I think we're going to allow access to that via the external API anyway, because of what's going on the controller. So, but this is just assigning an additional API, an additional virtual IP on that network.
Okay.
Yeah, I think so. HA proxy is bound to the external network, I believe, and then it is going to talk to Keystone over the internal network. I think that might be how that's going to be configured there. Yeah.
So one thing I'll point out is, with these networks that we're using for network isolation. So you'll notice here when I do a Nova list, they don't show up, and that's because we're not assigning them as part of the Nova OS server resource. We would need to do some extra work in Ironic and Nova to make that play nicely, but we're basically assigning ports for IPAM and just using the heat nested stack template to manage them. So, essentially we've got a heat object that represents a server, and that's how we assign the ports. So I say that to say that if you do want to query the ports assigned to all your servers, you can do that, and you would use the heat stack to get at that information. But the Only, for accessing my instances, I do typically just look at the output of Nova list and, you know, shell in with the control plane IP address, which is usually what I think most people prefer to do. Looking at I hear machines rebooting, so we should be coming active here in just a second. So we've got one machine, so this should come online shortly. So let's see here. Ping this. When it pings, I'll shell in real quick, and we'll look at what's happening. These machines I'm using are a couple years old now, so apologize for the delay, but it's not too bad.
Is that why you can hear them booting?
Well, yeah, that's my power switch is should come online shortly. Okay, almost there. Oh, I need to get my. Wait, is it? Did I not get? That's not letting me in. I thought I was allowing that. I think I might have missed the window there. The heat metadata might be configuring OSNet config right now. There, yeah. All right, so yeah, I missed it, but let's see if I can get something else. So OSNet config is actually already run, which shows you how fast the metadata gets applied locally. But this is basically, OS collect config ran that. Let's go up and look at the output. So you can see here it's writing out an OS config template. It runs OS refresh config, which runs OSNet config, and then it's going to apply it. And VLAN. You can see here, down here was our configuration file. It's adding the VLANs. It's running IF down. Here it's running IF up. So that's what it looked like. And so I don't think So yeah, validation occurs in the same agent. OS collect config runs the ping test. And so it's going to run, like I said, it's going to run a ping test in my environment back. I only have one controller right now, but it'll run a ping test back to the controller, and that basically validates that that all the VLANs are there, they're working. Switching gears a little bit, so that's kind of the underpinnings of the physical network configuration. It's probably another talk, but for all of the sort of neutron, like higher level, like virtual configuration, there's basically two areas that stuff takes place. One would be just normal heap parameters. If there's any sort of like neutron, well, I can give you one example. So like, some of the net config environments, single NIC with VLANs, so if you want to set neutron external network bridge, there's a comment here. This basically controls what's happening in your L3 agent.ini file. And it's a parameter. So, you can imagine any sorts of neutron or up configuration is going to be heap template parameters, or if you wanted to use actually, Puppet higher settings directly, you could use that as well. And then, once you actually bring up your overcloud, all of your overcloud networks are actually sort of a post-deployment configuration side. So, but that that may be impacted by what you've done on your physical network. So, well, it will be impacted by what you've done on your physical network. So, all of this has to line up. But there's a lot of sort of stuff and complexity that you can go into on that area as well. And so we have some examples in TripleO.sh, and I think there's some examples in TripleO docs about how to do the post-deployment network configuration with Neutron for some of the various setups. But yeah, this was really just focused on the physical side. So I think that's pretty much what I've got, unless there's other questions. Any other questions or things you guys want me to show or go over? I mean, I could show you my switch, but that's pretty proprietary to my environment, so I don't know that anybody cares about that.
I have one question. Like when we are doing the install through the quick start, mostly it is the provisioning network which is on VXLAN. I think the provisioning network is what we have. That is the only network on which all of the internal, external, everything is working. Is that correct?
Yeah. So I mean, I think your question is, by default, we only have one network, and that's the control plane. Does that answer your question?
Yeah. And how in the virtual environment can we make it more than one network? I mean, that's a question I have.
Oh, okay, I see. Yeah, so there's a couple of ways you can do that. You can actually use VLANs in your virtual environment. That's one way. Or you can use multi-NICs in your virtual environment. That's another way. So in the case of virtual NICs, what you would be doing is you would be creating. I'll show you my. Let me get the window here. Versh dump XML seed. Well, here. So in the case of virtual NICs, what you're effectively doing is in your virtual environment, you're literally giving yourself multiple interfaces. So you're basically going to have as many interfaces as you'd like. And so you can do that, and just you would for every single interface, you're just going to have a common bridge that you share for all the instances. And so if you do that, you've effectively, by default, OVS bridges they trunk VLAN packets, so you don't have to worry. And so you can basically do that however you want at that point. You can use VLANs or just have, straight up interfaces. Does that answer your question?
Yeah, and you said it's possible over VLAN also?
Yes, it is. I think there's a patch. I think there's an example of how to do that actually in TripleO docs. I'd have to look again, but I believe we posted a patch. The same question came up at one of the meetups, and I think we pushed a patch there. But yeah, it is possible. You can ask me. I'll look. You can ping me on IRC later and see.
Yeah, thanks.
Any other questions?
Yeah, one more thing was I was wondering, because in real-time deployments, mostly where I get confused is the provider networks. If there are multiple provider networks to a, let's say, the external interface, I think we can configure through OSNet config. I think, I'm not sure. Do you know how it is done?
Yeah, I mean, you can configure as many networks as you would like with OSNet config, and whether you use them for provider networks or something else, I mean, that's sort of up to the interaction of how you're configuring neutron and what bridges and interfaces you're pinning neutron to, and then you can then configure the provider networks in neutron, accordingly as well. So we unfortunately don't have a generic sort of like give me 8 provider networks option in the default heat templates. But if you create your own config templates, like network config templates, like we went over a few minutes ago, you should be able to drive your own provider network configurations, I think, and do what you need. One other thing that reminded me of, there are some tools out there. Ben Nemec just blogged about this earlier last week. He has a network. It's a command line tool that allows you to generate. It's a network sort of template generator. So you can check that out on his blog. And it'd be nice if eventually we could converge that into a combined CLI/UI tool that looked basically the same. But the templates were very much architected to be to be customized, because there's just so many types of development, or so many types of networking environments out there that you pretty much need that. So using that tool, I don't actually know if it does provider networks, but you might also be able to add them via that way as well. Okay, any other questions? I think it's time to get back to coding then.
All right, thanks a lot, Dan. Jason, did you want to show any of the network topology stuff in the UI, or?
I have one better. I have Liz to show it.
Okay. All right, well, we got
Yeah,
about
I can,
10 minutes. Yeah, if you wanted to show some of that real quick.
Sure, yeah. I'll give a real quick rundown, and it'll probably be more of a, hey, check out what I'm doing and go comment on it, or I could do another session where we just, rip it apart and make it better. So what I've started to do is pretty much try and understand most of the stuff that Dan shared on the back end of things in the CLI and everything, and put together some wireframes where we represent doing this type of work in the UI. I put together a flow specifically around network configuration and topology. So I'll just kind of jump through here. If you haven't seen the UI before, the idea is that the user would come to a deployment plan page and go through this workflow, steps 1 through 4, to actually get to the action of deploying, being able to do everything that they could do on the CLI side, just in more of a, scripted, here's what we recommend you do and what order you do it in type way. So the user would first register some nodes. This is where they'd be presented with, you can either manually add new nodes or upload, a JSON file, the instack.json file that we recommend to get some nodes in your system. And I'm just showing this within the network flow so that I can explain, at what point you might want to jump into networking. On step 2, what we're doing, we actually have a default plan. So the default currently in the wireframes at least say, you have Neutron with the XLAN as default. You can jump in and edit that configuration. And we have a section for basic settings where it's high-level things like the name, what templates you're pointing to. And then I have a column here for networking. And this is where we start getting into specific networking things that I truly, really do not understand at the level that a lot of people do, or, at least folks like Dan, you understand. So this is where I'm kind of looking to lean on you guys, the networking guys specifically, on, what really makes sense to show here. But the idea is that you'd have a high level set of networking options. It would probably change things behind the scenes based on what you chose here. But there is an option to go ahead and jump into more advanced network settings. And you can see here there's a column for compute, storage, and also add-ons, and there'd probably be advanced settings for each of those. But for this flow, I'm showing jumping into the advanced network settings. And here's where I'm thinking about things like, what fields do we want to show from those heap templates, and the templates based on some of the higher level settings that you've actually chosen, some of those basic settings. So these might change based on, Neutron with VXLAN versus GRE or whatever it is. And then something like, do we want to have them be able to, add new subnets and define which traffic type is going on those subnets and showing, the actual address here. This is being taken out of, some of the stuff we did for Stay Puffed that seemed to be pretty well received. And I think I just need to figure out, does it still make sense, here with, moving it into TripleO, or did it work for Stay Puft for some reason that it doesn't work anymore? So kind of looking for feedback on this as well. So a user being able to add a new subnet, as I mentioned. After they do, this configuration, and, we can extend that to whatever we really want it to be. Step 3 is to assign nodes. This is a modal that comes up where the user can select one or more nodes, actually assign them to different roles. Once they've gone ahead and assigned nodes to roles, we have the concept of viewing a network topology, and this is probably what Jason mentioned early in the call. So the user could click on that, probably see a full screen pop up of what their topology currently looks like. And I'm actually going to bring this up in a full screen because it's just better quality here. I can zoom in a little bit easier. So the idea here is this is purely read-only for now, but the user would be able to see how many nodes of which role they have defined in this deployment, any, the layout of the NICs and which are bonded, which are not. And then they would be able to see their undercloud with those networks, what they're connected to, and then which subnets, what networks they're actually, those NICs are running on or connected to, I should say. And the idea is to show some details like VIPs about each one of these subnets. We had an idea to have some sort of hover over state as well around potential IP ranges for each of these. And yeah, I think that's where we're at for now. Definitely still in, first draft stage. So looking for as much feedback as you guys have to give on this.
That's not entirely true. This is second draft.
Sure. Has never been implemented and is still in design phase. We'll put it that way. There's like 4B is what I named it. So I try and, save things that we've actually talked about just in case, because as you guys probably know, in your world as well, we will typically do like a full circle and be like, remember that thing we first did? Can we go back to that? So I try and save as much as I can. And the last thing I wanted to show here is we have a section called nodes where the user can drill in, and Fuel does this where you're allowed to, go ahead and single select or multi-select and configure the interfaces on the node level. So the idea here is that, a user would be able to, see, those NICs and be able to, create bonds and assign which networks they are actually connected to. And add VLANs. I don't have a screen showing anything around VLANs, but I probably should add something. And I think that's it. I know that's a lot to intake, and I can share this link with you guys here in the BlueJeans chat And please, like I said, feel free to rip it apart. That should work. I'll share this one just in case that one, for some reason, did not work. And 1 minute for comments, questions here on this call.
Yeah. Thanks for sharing. Appreciate that.
And no problem.
All right. Anybody got any final feedback or questions before we wrap up? All right. Well, thanks for joining as always, and I'll update the Etherpad with the recording link.
Yeah, thanks everybody.
See you later.
Thanks. Bye.
Thank you, guys.